Welcome to this explainer. Every single time you swipe on a screen, click a link, or even just skim a headline, you're interacting with a massively complex, meticulously designed system. And today, we're going to decode exactly how that system works. We're taking a journey from the absolute microscopic building blocks of basic data all the way up to the global front lines of modern cyber warfare. It is a fascinating look into the invisible architectures that literally govern our digital lives. Let's get into it.
To kick things off, we have to start with this foundational idea from media theorist Marshall McLuhan. He famously said, "The medium is the message." So what does that actually mean? Well, he's basically telling us that we can't just get distracted by the content of what we're consuming. The actual technology, the medium that delivers the information to you, fundamentally alters its meaning, its scale, and its total impact on society. Keep that idea right in the back of your mind as we go through this.
Here is our roadmap for today. We'll be covering the anatomy of information, how innovation spread, organizing the infosphere, information warfare and ethics, and finally, the security blueprint.
Right, let's jump straight into Section 1, the anatomy of information.
Okay, so the absolute most crucial thing to understand is that not all digital inputs are created equal. Think of it like a pyramid. This is what we call the DIKW hierarchy, and it's essential for understanding information systems. At the very bottom, you just have raw, uncontextualized facts. That's data. When you process that data, it levels up to information. Then, when you combine that information with human experience, it becomes knowledge. Finally, at the very peak of the pyramid, we have wisdom. And wisdom is where human judgment and ethics come in, answering the big question, what is actually the right thing to do?
To put that into perspective, let's imagine a television network. The raw viewing logs of who tuned in, that's just data. When analysts crunch those numbers to find out the target demographic, that becomes audience ratings, or information. If the network uses those ratings to build a smart scheduling strategy, they're applying knowledge. But deciding to pull a sensationalized, potentially harmful program, even though it would get huge ratings, that requires that top tier. That is wisdom.
Moving right along to Section 2, how innovations spread.
Human behavior is actually incredibly predictable when it comes to adopting new technology. Everett Rogers mapped this out brilliantly with his diffusion of innovation's S-curve. It basically shows how new tech spreads like wildfire through society. It starts on the left with the risk-taking innovators and slowly moves all the way over to the skeptical laggards. But the absolute game changer here is the critical mass point. Once an innovation gets adopted by just 10 to 25% of a population, it hits a tipping point. The spread becomes totally self-sustaining and just explodes into the mainstream.
But how do we, as individuals, actually get pushed to that point of adoption? We all go through a 5-stage process. Stage 1 is just learning a technology exists. But Stage 2? Persuasion. That is the ultimate battleground. This is literally where psychological warfare comes into play. Bad actors use targeted persuasion techniques and perception management to hijack this exact stage. They exploit peer pressure and interpersonal networks to guarantee you form a favorable attitude toward their narrative, whether it's actually true or not. If you want to control the world, you have to win the persuasion stage.
Which brings us to Section 3, organizing the infosphere.
Now, when massive organizations structure all this technology, they use an IS taxonomy pyramid. At the base level, you've got transaction processing systems, or TPS. These are the workhorses doing the daily, high-volume grind. Think processing millions of credit card swipes. As you go up the pyramid, the systems start aggregating that data all the way up to executive support systems at the very top. These provide high-level, summarized dashboards so senior leaders can actually drive long-term business strategy.
Let's ground this in a real-world example. Take a major institution like Malaysia's Maybank. Sitting right there in the middle of their tech pyramid, they use what are called Decision Support Systems, or DSS. These systems take vast amounts of raw data and run complex analytical models to help managers evaluate credit scores or flag fraudulent transactions in real time. It's a perfect example of technology directly augmenting human judgment when split-second decisions are absolutely crucial.
But here's the thing. You can't just buy these massive, complex systems off a shelf. Organizations have to build them using a structured process called the Systems Development Lifecycle, or SDLC. It moves step by step from planning and analysis through design all the way to implementation and maintenance. It's designed to ensure that the tech being built actually maps to broader strategic goals, like perfectly aligning with national frameworks such as Malaysia's My Digital Blueprint.
Choosing how you execute that cycle is a make or break strategic decision. The old school way is the waterfall method. It's super linear, very rigid. You have to finish one phase completely before starting the next.
The problem? If the market suddenly changes, you're stuck, which leads to high failure rates. Actually, scratch that. It's more like guaranteed headaches. That's why today, modern orgs heavily favor the agile methodology. It's iterative and highly flexible. You build the software in quick 2 to 4 week sprints, which lets the team adapt on the fly.
All right, moving into Section 4, Information Warfare and Ethics, the real front lines.
To truly understand modern algorithmic warfare, we have to be super precise with our language. First, there's misinformation. That's false information, but it's shared without malice, kind of like an honest mistake. Disinformation, however, is false and deliberately crafted to deceive you. And then we have malinformation. This is weaponized truth. It's genuine, real information maliciously broadcasted just to cause harm. State actors use these as weapons of cognitive warfare. Using cultivation theory, they relentlessly expose a population to disinformation to fundamentally warp their perception of reality over time. And it gets darker. They also engineer a spiral of silence. By using armies of algorithmic bots, they create this fake illusion of overwhelming consensus, which terrifies dissenting factual voices into self-censoring just out of fear of isolation.
And it's not just trolls and bots on social media we need to worry about. We have to look at the massive corporate and state actors controlling the infrastructure itself. Media scholar Brian Winston came up with this brilliant concept called the law of the suppression of radical potential. Basically, he argued that powerful institutions will intentionally suppress truly disruptive technologies just to protect their own dominance. They'll use patent monopolies or regulatory capture to essentially put the brakes on innovation, just to make sure the status quo isn't overthrown too quickly. And these underlying power dynamics absolutely dictate our legal frameworks around the world. Look at the data protection laws. The EU has the GDPR, which is incredibly strict and enforces powerful rights like the right to be forgotten, holding nearly everyone accountable. Contrast that with Malaysia's Personal Data Protection Act of 2010. It heavily regulates commercial transactions, sure, but it notably exempts federal and state governments from its core principles. So as you can see, the legal architecture really dictates who holds the balance of power in the infosphere.
Finally, let's wrap up with Section 5, the security blueprint.
So with all these vulnerabilities, how do we actively defend ourselves? The absolute bedrock of all cybersecurity is called the CIA triad. And no, definitely not the intelligence agency. It stands for confidentiality, integrity, and availability. The tricky part is that it's a constant trade-off. Think about it. You could make a system 100% confidential and secure by locking a hard drive in a vault and unplugging it from the internet. But then you've completely destroyed its availability. Nobody can use it. Good security is always a balancing act. To maintain that delicate balance against serious threats like ransomware, social engineering, or crazy AI deepfakes, cybersecurity experts rely on formal mathematical models. For instance, the Bell-LaPadula model is all about confidentiality. It strictly prevents users from reading data above their security clearance. On the flip side, you have the BIBA model. BIBA focuses entirely on data integrity, making absolutely sure that low-level, untrusted data cannot be written up into your highly secure critical databases. Honestly, though, the old-school idea of a safe, walled-off corporate network, that is completely dead. Today, the gold standard is zero-trust architecture. The core philosophy here is wonderfully paranoid. Never trust, always verify. It operates on the assumption that a breach has already happened, so it treats every single access request, even if it's coming from the CEO's laptop right inside the company headquarters, as a potential threat, requiring continuous, strict authentication.
We have covered a massive amount of ground today, moving from the microscopic building blocks of data all the way up to zero-trust cybersecurity architectures. But as we look toward the future, I want to leave you with one really pressing question to think about. As artificial intelligence increasingly automates both the generation of disinformation and the very systems we use to defend against it, who ultimately controls the truth? It's a huge question to consider as these autonomous systems continue to shape our reality. Thanks for joining me on this explainer, and remember to always keep questioning the architecture around you.